That's a resistor. That's a common passive component in electronics. That's a power resistor. That's a capacitor. That's a ceramic capacitor. Electrolytic capacitor. Same component, different values, used for different things. That's an inductor. That's a coil of wire. And they're the three basic components in electronics. But there's a fourth. And it looks like that. Well, it doesn't actually. That's what 16 of them look like if they're in a dip package. And they are memristors. Now, the memristor is a little bit more exotic than these components. The resistor, the capacitor and the inductor, well, the resistor has no memory. The capacitor does have a memory in some ways because you can charge it up, so it remembers that it's been charged. The inductor is sort of similar. You can charge it up, but you do it with current and you create a magnetic field, and it does take time for that to collapse, so you can sort of say that that's got a memory as well. But obviously a memristor, it's got lots of memory because it's in its name. So these are pretty exotic at the moment. I'm not really aware of anyone else who's selling these. You can actually go online and buy these. They're not cheap though. One of these packages with 16 memristors is around about $100. It's a bit less than that actually. So you're looking at about £4, £4 I say, roughly per memristor. I mean, that's quite a lot because there's 16 in here, but it's not really any different to the first blue LED that I bought many years ago, which was something around about £5 for a single LED. But these are completely different beasties. So at the moment I've only bought these to basically play with, and obviously to play with it I don't really want to just sit it on the desk and look at it. I want to actually do something with it. So I've put together this, which is a Arduino Uno Shield, which lets you investigate whatever's plugged into this socket. So what I've got here at the moment is a test PCB, which has got a similar footprint to the memristors, but it's got an assortment of resistors, diodes, Zener diodes, and there's a capacitor and a linker wire, which lets me do effectively curve tracing on these components. So what we've got is a D2A and some op amps which generate a test voltage which goes through a current limit resistor straight across whatever component is in this socket here that has been selected by these analog switches. There's analog switches here, and they select one of the devices in this package, this footprint. So this has been designed to be like one of these packages, except instead of memristors we've got known components there, so I can calibrate and check that this circuit and my code is working before I put the memristor in. Unfortunately I made a mistake or two with the PCB, which is why these components are on little daughter boards. I got the footprint wrong. Turned out to be quite useful because I can actually put test points very easily on the variable, so I can attach a scope, and that's what these bits here are. I could do another PCB, I don't know if I'm going to at the moment. I might not, where I fix all the problems on this one, but this is a prototype, so I've got a wire here. But overall it's pretty good. It does work. And you can get traces from diodes and memristors. There were a few little problems along the way. Unfortunately, when I laid the board out, I got the memristor layout wrong as well. So you have to put that in a daughter board as well. It doesn't make much difference to the testing of the component. So it'd be nice to fix all that on another board, but I don't know if I will. So details and curves and so on are on my blog. And the PCBs, I've got a few of these PCBs available, but obviously you need a bit of work. You need to do some wiring, and you need to put things in these daughter boards. The main problem is if you're going to buy memristors, I bought one of each different type because the devices themselves are they're basically they're sort of chemical devices. They're electrochemical, totally unlike an inductor or a capacitor or a resistor, really, in that they're not simple constructions. It's not just a coil of wire or a thin bit of wire or two plates. They're much more complicated than that, and they're basically electrochemical, and there's a stacking of layers of different elements, different chemicals, and you can get memristors that are made from different, or some of the layers, one of the layers is different, a different element. So there's a carbon memristor, a tungsten and a chromium. They're the ones that I've got. There was also a tin, but I don't have any of those because they were out of stock when I looked to buy these. So I've got 3 different types of memristor. Each package is the same type. So what have we got here? We've got, it's very indistinct, that's chromium, and this one is carbon. They look the same from the outside. Let me get the other one. Here we go. So this one's tungsten. It's written on the package, but it's written in a very dark bit of writing there. So I've had a look with a microscope. Unfortunately, there's a bit of epoxy on top, so I couldn't use my my wafer inspection or metallurgical microscope to get down there and look in detail. You just can't do it physically. But I've got some photos of a USB microscope that I put on there, and you can see what they're like. They're not very interesting. They're just grey rectangles, which is fine. The current voltage curve you get out of it is much more interesting though than most of these components, because it's got a kink in it. It's a sort of infinity shape, which is where the symbol from this company, which is Knowm, where their symbol comes from. So that infinity symbol is roughly the voltage current curve that you get out of these memristors. And they do, remember, you can sort of regard them as a programmable resistor. You can program, by putting a certain current through it, the resistance that memristor will have, and it persists. You power it down and back up and it's still got that resistance. So I'm going to do some playing around with these. At the moment I've only got curve tracing, but I'm going to do some other stuff, I think, and see whether I can use them to store things and so on. They are pretty strange devices though. They're not really like these at all. I mean, they might be useful. There's people using them for neurons, because they have the similar sort of characteristic, but well, we'll see. So you can, when you use them as neurons, the resistance that they've got is the sort of connection, I suppose, or the neuron weight. It's all quite interesting. But yeah, so that's my test kit at the moment.